Hello students, today we will see the derivation of Hamiltonian function that is h and Hamiltonian canonical equations that is Hamilton equation of motion from Legendre dual transformation. Okay, in last lecture we have seen what is Legendre dual transformation. So Legendre dual transformation equations are u is equal to del f by del x, v is equal to del f by del y and x is equal to minus del f by del u. Suppose this is equation number 1 and we have to consider, let us consider that the transformation from Lagrangian system to the Hamiltonian system. Okay, consider a transformation from Lagrangian to Hamiltonian. So f is equal to L and f dash is equal to h. Okay, and we know that the Lagrangian function, it is the function of qk and qk dot. So Lagrangian is the function of qk and qk dot. So we'll consider x is equal to qk dot and y is equal to qk, as well as h is the function of Hamiltonian is the function of pk and qk. Okay, so in this we will consider u is equal to pk and y is equal to qk, because we are transforming the set of bases from xy to uy here. So Lagrangian is the function of qk dot and qk. So here x is equal to qk dot and y is equal to qk, and here the second basis set we are transforming into u and y. So here h is the function of pk and qk. So here u is equal to pk and y is equal to qk. So x is equal to qk dot, y is equal to qk, u is equal to pk, and we know that v is equal to this v. See the equation number 1, v is equal to del f by del y, and f is L. Okay, and y is qk. So v is equal to del L by del qk, and we know that del L by del qk is pk dot. So v is equal to pk dot. Now x, putting the value of x, y, u, v, okay, in equation number 1. So equation number 1 implies, okay, therefore equation number 1 becomes pk is equal to del L by del qk dot. Since f is L and x is qk dot and u is pk, so del L by del qk dot is pk. Second, v is pk dot and f is L and y is qk, so del L by del qk is equal to pk dot. And third one, x is qk dot, f is L and u is pk, so qk dot is equal to minus del L by del pk. So we got these three equations. Okay, so suppose these are the three equations. Suppose this is equation number 2. Okay, now we know that f is equal to f minus ux, because in Legendre dual transformation we have defined new function, and new function can be related with old function by this equation. So f dash is equal to f minus ux, where f dash is h and f is L. Okay, we have already considered that f dash new function is h and old function is L, minus u is pk and x is qk dot. Since these are the terms involving k, okay, so we can take the summation, because for the particles of the system, summation over k, pk into qk. Okay, now it can be written as h is equal to minus, here we write this term first, plus L. We can take minus common. Okay, so by taking minus common, here is minus. Now we will shift this minus to that side, so we will get minus h is equal to summation over k, pk qk dot minus L. Okay, if we take the magnitude of this expression, so minus h become h, and we'll get this Hamiltonian function. This is nothing but the equation for Hamiltonian function, h is equal to summation over k, pk qk dot minus L. So this is the Hamiltonian function. So this Hamiltonian function we have derived from Legendre dual transformation. Now by using this Hamiltonian function, we will derive Hamiltonian canonical equations or Hamilton's equations of motion. So consider this Hamiltonian function, h is equal to pk qk dot minus L. Okay, now we know that h is the function, L is the function of qk dot and time t. Okay, so L is the function of qk dot and time t, and summation with this term and also summation with L. So summation can be separated. H is equal to summation over k, pk qk dot minus summation over k. L is the function of qk dot and time t. Okay, now we will solve this. Okay, we will solve first term and then we will solve second term. So we will differentiate this equation, differentiate above equation. So now this is the product rule in first term of derivatives. This is the first function and this is second function, and here we will apply chain rule of differentiation. Okay, so after applying differentiation here, pk derivative of second function dqk dot plus qk dot derivative of first function dpk. Here also del L by del qk into dqk plus del L by del qk dot into dqk dot plus del L by del t into dt. So here we differentiate summation over pk dqk dot plus qk dot into dpk, minus here we applied chain rule del L by del qk into dqk plus del L by del qk dot into dqk dot plus del L by del t into dt. Okay, now we will separate these summations, and we know that del L by del qk dot is pk. So in place of del L by del qk dot we write pk after this step. Now we have separated this summation. Okay, separated this summation with this term plus this summation with this term also. Okay, we have separated this. Now we know that del L by del qk dot is pk, so in place of del L by del qk dot from equation number 2, del L by del qk dot, we can write here pk. Okay, now we will separate the summation of this second term also. So separation of summation, so and open the bracket, so we will get this these three terms. Okay, now see first term and this fourth term. Okay, they are equal but opposite, so they will cancel each other. So we will get dh is equal to summation over k qk dot into dpk minus summation over k del L by del qk into dqk minus summation over k del L by del t into dt. Now del L by del qk dot is pk dot, we know that from equation number 2 again. So del L by del qk is nothing but pk dot. So suppose this is equation number 3, and also we know that the Hamiltonian function, okay, Hamiltonian function is the function of qk, pk and t. So now we consider that Hamiltonian function is the function of qk, pk and t summation over k. Okay, now we will solve this, differentiate this equation. So again we will apply chain rule on right hand side. So dh is equal to summation over, again, okay, we will differentiate this, dh is equal to summation over k del h by del qk into dqk plus del h by del pk into dpk plus del h by del t into dt. So after solving this we will get, now this summation with all these terms, so we will separate this summation. So after separating this summation we will get these three terms. Suppose this is equation number 4. So equation number 4 is belong to dh, and as well as equation number 3, this equation number 3, okay, this equation number 3 is also belong to dh. Okay, so we can compare this equation number 3 with this equation number 4. Okay, so this is equation number 4 and this is the equation number 3 from 3. This is equation number 3. Okay, we will compare these. So we can compare the coefficient of these. So after comparing, look at here. Okay, comparing above equation. So here is dpk, here is dpk. The coefficient of dpk is del h by del pk, qk, and here is qk dot. So qk dot is equal to del h by del pk. Here coefficient of dqk is pk dot, here minus is there, so minus pk dot. Here coefficient of dqk is del h by del qk, so minus pk dot is equal to del h by del qk. Here in the third term coefficient of dt is del h by del t, and here coefficient of dt is minus del L by del t, so del L by del h del t is equal to minus del L by del t. By comparing the coefficient of both this equation, equation 4 and equation 3, we will get del h by del qk is equal to minus pk dot. Second, del h by del pk is qk dot, and del h by del t is equal to minus del L by del t. So these three equations are called Hamilton's equations of motion or Hamilton's canonical equations. So these are Hamilton's canonical equations, and these Hamilton's canonical equations we have derived from Legendre dual transformation. So we have started with Legendre dual transformations equations. Okay, then we have considered the transformation from Lagrangian to Hamiltonian. Then we have transformed those equations in terms of L and H, pk, qk and qk dot. Okay, and by using those equation, okay, we will solve we have solved and we have reached up to Hamiltonian's function. And by using that Hamiltonian's function, okay, by using that Hamiltonian's function and Lagrangian's dual transformation equation, we have reached up to this Hamilton's canonical equation. So that's all for today. Thank you very much.